Okay, in this presentation we are going to look at random variables. In particular, we're going to look at a worked example of a discrete distribution where we have three values and we have to calculate the expectation and variance, the expected value and variance. Suppose x has the following probability mass function. Probability of 0 equals 0.2, probability of 1 is 0.5, and the probability of 2 is 0.3. Okay, you just notice there that there are three values and the probability of each of those three values adds up to 1. 0.2, 0.5 and 0.3 add up to 1. So there's only three possible values. Again, they are 0, 1 and 2. So we have three questions here. Calculate the expected value of x, e of x. Calculate the expected value of x squared, the expectation of x squared, e of x squared. And calculate the variance of x, i.e. var x. Okay, so just again looking at the probability mass function, essentially what we're going to do is base a lot of our calculations on these numbers here. Okay, so those probabilities are important. So we have a value of x, or three values of x, so three possible values of x, 0, 1 and 2, and for each of those values of x we have a corresponding probability. Okay, that's it in a nutshell. Okay, so calculate the expected value of x. It's calculated as follows: the summation for all values of x of the value of x times the probability of that value. Okay, that's how we might verbalize that equation there. That big symbol there is a summation symbol, just in case you're not sure. Okay, so it's each numeric value times the probability of that value, and we add them all up. So 0 is the probability of that is 0.2. So 0 times 0.2 is 0. 1 times 0.5, that's 0.5, and 2 times 0.3, that is 0.6. So the expected value of x is 0 plus 0.5 plus 0.6, which is 1.1. So the expected value of x is 1.1. Just as a quick remark, on the first of those three equation lines have a little dot there. That's just a multiplication sign. It's a little bit more discreet than rather than using the x. Okay, but that's just what it is. So calculating x e to the x e of x squared, the expected value of x squared. Now this is done the same way, almost the same way. There's just one slight difference. Rather than use the value itself, what we do is square the value, each of the values, and then multiply by the probability of x. Okay, that's the only difference. So the expected value of x squared, again, so what we're going to do is multiply each value square it, and then multiply it by its probability. So we have 0 squared plus times 0.2, which is 0. 1 squared times 0.5, which is 1 times 0.5, which is 0.5. And 2 squared times 0.3, which is 4 times 0.3, which is 1.2. So we end up with the expected value of x squared equals 0 plus 0.5 plus 1.2, and that equals to 1.7. So the expected value of x squared is 1.7. Okay, so moving on to the last one, which is the variance of x. To calculate the variance of x, we use the following formula. This is an important formula. It's essentially the key learning outcome for this video. The variance of x equals to the expected value of x squared minus the expected value of x to be squared. Now this is an important formula and you will be encountering it a lot. So this exercise really is justified by getting you used to working with this particular formula, okay? So from the previous calculations, we have the expected value of x equals 1.1 and the expected value of x squared equals 1.7. So essentially put these into our formula. The variance of x is 1.7 minus 1.1 squared, which is 1.7 minus 1.21, which leaves us with a difference of 0.49. So the variance of x equals 0.49. And that is the answer. If you not asked for here, but essentially the standard deviation of x is the square root of that, which is probably, I think, 0.7. Not asked for here, but, you know, could be asked for. Okay, we'll leave it there.